Hello, mathematicians, puzzlers, and other curious people. Once again, we are investigating a formula. Now, if this has come up for you as you're watching some different things on YouTube, you might be missing a little bit of context, so look for the link to a blog post in the video description so that you'll know why I'm doing some of these calculations. So the formula we're working with here is 4 to the nth power plus n to the fourth power, and we're considering the specific cases where n is even. In other words, if you take some whole number that we can call k just because we're not doing anything else with that letter, and double it, you would get n. So for example, if you wanted to look at the case where n equals 6, you could say, okay, k could be 3, and then that would work. So that just gives you some idea of why we're plugging in what we're plugging in. So we're going to try plugging in 2k everywhere n was. So we'll have 4 to the power 2k plus 2k to the power 4, making sure that we're applying the exponent to the whole thing instead of only to the k part. Then I'm going to say, okay, I'm going to use an exponent property, so a product to a power is the same as each factor being separately raised to that power. So we'd have 2 to the fourth times k to the fourth. And for the moment, I'm just going to bring the other term along how it is. Well, I know 2 to the fourth power is 16. And if I could get a 16 to show up in my other term, that would really help me out. So I'd really like to do that, and it seems like I should be able to because I've got a 4 right there. 4 to the power 2 would be 16, but then there's still that pesky k there. So what can we do here? Well, I know that 2k would not be changed if we put in a convenient 0. So that's what I'm going to do here. So I'm going to say, okay, we'll have 2k minus 2 and then plus 2. So remember, I'm not changing the value. I'm just doing a clever rewrite, so it's still equal. Now I'm going to use another exponent property, and I'm going to say, okay, we'd have this plus 2 here. Well, that's the same as if we got rid of that plus and made it another factor of the term. So we'd have 4 to the power 2 coming from that plus 2 there. And then we'd still have 4 to the power 2k minus 2. Okay, so we've rearranged this term here. And then we've got 4 to the power 2, which of course is also 16. So we've got 16 times 4 to the power 2k minus 2. So for example, if that k were 1, we'd be saying, okay, so we'd have 1 times 2 is 2, minus 2 is 0. So then that would be 4 to the power 0, which would just be 1. So there's our first term, and here's our second term. And then I notice both terms have a 16. So I can factor off that 16. And that tells me that whatever I get by plugging an even number into this formula, if I take k as, again, half of that even number and plug into this factor here and multiply that by 16, I would get the same number. So that tells me that 16 and whatever number I get here are factors of 4 to the n plus n to the fourth. So this is definitely composite. So check the blog post to see what happens next.